C. Now, we're going to discuss the different types of data and levels of measurement in statistics. Our class objectives will be, at the end of the class, you should be able to identify the types of statistical data, differentiate the different levels of measurement and methods of data collection, and last, apply the concepts of data statistics through solving real-life problems. Now, we're going to discuss and differentiate the variables and data and its importance and connections to our discussions for today. So what is variables? Variables are the characteristics or attributes that you're observing, measuring, and recording data. So variables, we can actually say that it is a memory location because of variables, we can able to have a data or a value. So what is a data? Data refers to observations and measurement which have been collected. So data, it is what the variables assume. For example, age of the students in elementary. So we can have 7, 8, 9, 10, 11, 12. In the first example, we can able to identify where is the variables and where is the data. So the variables in here is the age of the students in elementary because this is what the memory location. It is what we can able to have a data which is a 7, 8, 9, 10, 11, and 12. The second example is a brand of a cell phone. Brand as a cell phone is considered a variables because of this, we can have a data, we can have an answer, we can have a collected data. So the data is a sample, a Samsung, Apple, Oppo, Huawei, and Realme.
Types of data in statistics. So what is data in statistics? Data are measurements or observations that are collected as a source of information. Data are the individual pieces of factual information recorded and it is used for the purpose of the analysis process. So data, it is the raw of information from which statistics are created. It is also used to create new information or knowledge. Data are the facts and figures that are collected, analyzed, and summarized for presentation and interpretation. For instance, gender, which is the variable. Its data are male, female, lesbian, or gay. Data can be classified as either qualitative data and quantitative data. Qualitative data provide labels or names for categories of like items, while quantitative data measure either how much or how many of something. So, qualitative data also classified as nominal data and ordinal data, while quantitative data classified as discrete data and continuous data. So what are the types of data in statistics? These are the types of data in statistics: the nominal data, ordinal data, discrete data, and continuous data.
Now, let's discuss the different types of data in statistics. First, we have qualitative or categorical data. So, qualitative or categorical data are counts of the number of participants or observations in each category. This data is often described by percentages or other ratios. So, categorical data or qualitative data is descriptive data. So, this describes the quality of the things. This cannot be measured in the forms of numbers. This type of data is classified into groups, and there is no arithmetic operations possible in this type. So, in categorical data, there are two classifications, which are the nominal and the ordinal data.
Di ba ang qualitative data is data that is descriptive, depicts qualities and characteristics. So if there were a group of people in a room, qualitative data describe on how they feel, what they look like, what their clothes are, or the motivation of why they are here. So for example, examples of qualitative data is the color of the house, the smells of the socks, and the quality or the texture of the shirt.
So now, let's move on to nominal data. So what is nominal data? It's a type of qualitative data which groups variable into categories. You can think of these categories as nouns or labels. They are purely descriptive. They don't have any quantitative or numeric value. And the various categories cannot be placed into any kind of meaningful order or hierarchy. So, it is a type of data that is used to label variables without providing any quantitative value. Unlike ordinal data, nominal data cannot be ordered and cannot be measured. At this point, it's important to note that nominal data may be represented by numbers as well as words. However, these number labels don't have any kind of numeric meaning. Although you are using numbers to each category, these numbers do not represent any kind of value or hierarchy. You can identify nominal data according to the following characteristics. Nominal data are categorical and the categories are mutually exclusive. There is no overlap between the categories. The nominal data are categorized according to labels which are purely descriptive. They don't provide any quantitative data or numeric value. Nominal data cannot be placed into any kind of meaningful order or hierarchy. No one category is greater than or worth more than another. So, as you can see, nominal data is really all about describing characteristics.
So now, I'm going to show you the examples of nominal data, which is one of the type of qualitative data to deepen your understanding of nominal data. So for example, the shapes. The shapes here will be our variable, and our data will be a circle, a square, a triangle, and a rectangle. In nominal data, remember that the data is grouped into categories. Since it is qualitative data, then it has to be a words, a nouns, and a labels. But sometimes the labels can be a numbers. So, for us to easy to identify the data, we can denote that the circle is as 1, the square is number 2, triangle as number 3, rectangle as number 4. However, the number labels doesn't mean or doesn't include any meanings. So the circle, square, triangle, and rectangle is an example of nominal because it doesn't include any rankings, any order, or any hierarchy. It is incategorized. Another example will be a names. And the name, since the names is the variable, then the data can be an Anna, James, John, and Elsa. As we compared my first example and the second example doesn't have any number, but it is example of nominal since it doesn't have measured by numbers or ordered. Another example will be the colors. It is our variable and our data here will be the red, black, green, and blue. And that would be all the nominal example.
So another type of data in statistic under categorical is the ordinal data. When we say ordinal data, it is defined as the qualitative data whose values are in order. So when we say qualitative, the data is not easily reduced to numbers and answerable with the question how, what, and why. So let's say for instance, in economic status,
So in economic status, we can define the categories as low, medium, and high. So the economic status here is our variable, and then the data that we input is the low, medium, and high. So in order siya. So from lowest to highest. So dili siya pwede na high, low, and then medium. So it must be in order. Another example is the rank in a competition. So the data that we can input is the first, second, and third. So our data is the this first, second, and third, and then our variable is rank in a competition. So as you observe, yahang data is in order siya naka-arrange. Then another example is the time of the day. So the time of the day, we can categorize the data as morning, noon, and night. So dili pwede na morning, night, and noon. It must be in order, morning, noon, and night. So in ordinal data, we must remember that we must define the categories and then order the categories.
Now, I will going to discuss about the quantitative or numerical data. Quantitative data is also known as numerical data, which represents the numerical value, which it can be asked by how much, how often, and how many. Numerical data gives information about the quantities of a specific thing. The quantitative data can be classified into two different types based on the data sets. The two different classifications of numerical data are discrete data and continuous data. So quantitative data are measures of values or counts and are expressed as numbers. Quantitative data are data about numerical variables, which will be asked by how much, how often, and how many. While the qualitative data are measures of types and may be represented by a name, symbol, or a number code. So qualitative data are data about categorical variables, which will be asked by what type or what color of the hair. Just remember that the data collected about a numeric variable will always be a quantitative, and data collected about a categorical variable will always be qualitative. So therefore, you can identify the type of data prior to collection based on whether the variable is numeric or categorical.
This is the example of quantitative data, but before I going to explain the example is, we need to remember that quantitative data is the opposite of qualitative data, which means qualitative data is seeking word data or by category, and quantitative data is seeking numerical values or data. So this is the example of quantitative data, which is height, age in years, and weight. So example of height is when you going to know what is the height of your classmates. So expected na yun na tubag yung siya numbers. Okay, height man no. Dahil po mingon siya long, mingon siya short siya. So mingon siya og mga values nga numbers. And especially in age and weight.
Let's proceed to the discrete data. Discrete data contain only discrete values. Discrete information contains only a finite number of possible values. Those values cannot be subdivided meaningfully. Here, things can be counted in whole numbers. So discrete data is a count that involves integers. Only a limited number of values is possible. This type of data cannot be subdivided into different parts. Discrete data includes discrete variables that are finite, numeric, countable, and non-negative integers. This data type is mainly used for simple statistical analysis because it's easy to summarize and compute. In most of the practices, discrete data is displayed by bar graphs stem and left, plot, and pie charts.
So this is the example of discrete data. So just remember that the discrete data cannot be divided, and discrete data is finite. So whole number gani siya. Ang mga answer dyan niya kay whole number. So example, the number of student in math 2A attended in math 20. So assuming nga ang ni-attend sa math 2A nga class is 40. So dili ta mo makaingon nga 40 and a half student because wala may tao nga half, di ba? So whole gid siya. Whole. Another example is the number of teachers attending the assembly meeting. So assuming 30 teacher is attending the assembly meeting, so exact siya, bali whole number jud ang iyang answer. Di ta mo kaingon nga 13 1/4 kay lain pud nga na teacher nga 1/4. So whole good. And lastly, the last example is the number of computers in DDoC New Bataan branch in the computer lab. So expected nga ang answer pud diri kay whole number.
So, the second type of the quantitative data is the continuous data. Continuous data is a data that can take any value. So, kabaliktaran ni siya, opposite ni siya ang continuous data sa discrete data. Kaya discrete data is finite and ang continuous data is infinite data.
So the continuous data, it can be broken down into fractions and decimals. Continuous equation we say are measured, we can measure them, such as height.
So now let us proceed to the example of
Continuous data. First is something you can often see is time. Time is continuous. You can have half a second or half an hour. So the variable here is the time and the data is half an hour. Second, something would be temperature. Temperature is usually like 75.7 degrees. Temperature can be written fractions or decimals. So the variable here is the temperature and the data is the 75.7 degrees. Something else would be distance. All these things are measured and it could be weight and height. So it is important to remember that the difference of discrete data and continuous data is that discrete data cannot be broken down into fractions and decimals, while the continuous data, it can be broken down into decimals and fractions.
And now, let's proceed to the next part of our discussion, which is the levels of measurement in statistics. So what is the levels of measurement in statistics? It is also called scales of measurement. Tell you how precisely variables are recorded. In scientific research, a variable is anything that can take on different values across your data set. Example, height or test scores. So the levels of measurement in statistics is a classification that relates the values that are assigned to variables to each other. In other words, it is used to describe information within the values. And there are 4 levels of measurement in statistics that was developed by psychologist Stanley Smith. And those are nominal, ordinal, interval, and ratio.
So when carrying out any kind of data collection or analysis, it's essential to understand the nature of data you're dealing with. Within your data set, you'll have different variables, and these variables can be recorded to varying degrees of precision. If you're working with data in any capacity, there are 4 main data types or levels of measurements: the nominal, ordinal, interval, and ratio. Here, we'll focus on nominal level of measurement. So, what is nominal level of measurement? You can categorize your data by labeling them in mutually exclusive groups, but there is no order between the categories. The nominal level of measurement is the first level of measurement and the simplest. These levels and groupings don't have any order or hierarchy to them, and it classifies qualitatively. In other words, it divides them into name groups without any quantitative meaning. Another way to think about levels of measurement is in terms of the relationship between the values. There is no relationship between the categories. When using the nominal level, always bear in mind that there is no order to the group you use to classify your variable. One category is not higher than, better than, or greater than another.
And now, I'm gonna show you the example of nominal level. First is the status. So, remember that nominal level is not about ordering or not about hierarchy or anything. It is just categorized. So, first example is the status. Status, the data will be the single, taken, married, widowed, separated, and divorced. So remember, our variables here is the status and our data here is this area. Another example is the BSN majors. The data will be mathematics, English, social studies, and science. Again, our variable in these examples will be the BSN majors and our data will be this area. And the last example is symbols. Symbols will be, it can be comma, semicolon, colon, question mark, a dot, apostrophe, and an exclamation point. Again, remember our variables here is a symbol and will be our data, and that is the example of nominal level.
The second type level of measurement is the ordinal. So when we say ordinal, it is a quantitative data which have naturally occurring orders and the difference between is unknown. It can be group, name, and rank. So the ordinal scale it has a variable of measurement scale used to simply depict the order of a variable and not the difference in each of the variables. So let's say for example, student class designation. So we have the variable student class designation and the data is freshman, sophomore, junior, and senior. So this is an example of an ordinal. So the students can be grouped as freshmen, as first year, sophomore, second year, junior as third year, and senior for the fourth year. The next example is the competition in run, sa mabilisan takbo. So we have the data, champion, first, second, and third. So according to the definition earlier in ordinal that the difference between the two data doesn't matter. So for example here, champion. So the champion got 2 minutes and 48 seconds and the first is 3 minutes. So the difference between the two is 12 seconds only. So this difference, the 12 seconds, doesn't mean that the second runner is 12 seconds then. So the difference between the data here is unknown. So it doesn't matter. So the only thing that we must see is that the champion is their ranking. So ito yung pinakamabilis. So si 2 minutes and 48 seconds. Then the first 3 minutes. The second 3 minutes and 15 seconds. Then the third 3 minutes and 40 seconds. So in ordinal level of measurement, remember that it is effectively used in surveys, polls, and questionnaires due to the simplicity of analysis and categorization.
Now, I will going to discuss about the third level of measurement, which is the interval. So interval is an order or ranking can be imposed on the data. Precise differences between the ranks do exist, and there is no meaningful zero. Interval scales present more information than ordinal scales, in that they provide assurance that the difference between values are equal. In other words, interval scales are ordinal scales
but with equivalent scale values from low to high intervals.
So this is the example of interval level. The temperature in a classroom of Math 2A is 35 degrees Celsius, and English 2A is 30 degrees Celsius, and Social Studies 2A is 25 Celsius. So the variable there is the temperature of the classroom, and the data there is the 35 degrees Celsius, 30 degrees Celsius, and the 25 degrees Celsius. So we always remember that interval can be order or ranking that can be imposed on data. So para makabaluta, so pwede na to siya i-arrange through sa pinakainit sa dili kayo init. So the next meaning of interval level is precise differences between the rank do exist. So to know the differences of both variables is we need to subtract the data. So we can know the differences or the interval of the interval. So the next example of interval level that we should know is there is no meaningful zero. So it means that the zero there is not the lowest value.
Next, we have the ratio. You can categorize, rank, and infer equal intervals between neighboring data points, and there is a true 0 point. So in ratio, there is a meaningful zero, and this can be order or ranking and can be imposed on the data. And ratio level measurement, precising difference between the rank do exist.
The highest level is the ratio because it has the same properties as the interval level. The order and the difference can be described, and additionally, ang nakanindot sa ratio is that kanang na siya true zero, which means zero basis siya, and the ratio between 2 points has a meaning.
So, example of ratio is that mass 80 kilogram, 40 kilogram, 10 kilogram, and 0 kilogram. So the variable here is mass, and the data is 80, 40, 10, and 0 kilogram. So makita nato diri sa order nga, ang pinakadako ay ang 80 kilogram, which is ang 80 is mas bugat sa 40, and ang 40 mas bugat sa 10, and 10 mas bugat sa 0. So diri makita nato ang true zero sa mass, which is walay matimbang sa 0 kilogram, and it is because we cannot have a negative mass. Maong kaning mass is a ratio level. And last, we will say that in the ratio between 2 points has a meaning. So, ang pasabot ani is ang 80 kilogram kay balik ka upato ng kabugaton kumpara kang 40. And so we have true ratio here, which is sa 80 and 40, which is 2. And sa 40 and 10, kay ang 40 is mas bugat siya or bali ikaupato niyang kabugaton kumpara kag 10. So pasabot nga ang ratio nato diri sa atong mass has a meaning. And this is an example of ratio level. To summarize the discussion about the levels of the measurement, based here sa measurement scale is ang pinakababa ang nominal level. Kung may nutag nominal level, we can name, but dili na ito makuha yung order, difference, ug wala siya true zero. When we say ordinal, we can name, makuha ko na ito yung order, but wala siya difference, o dili na ito makuha yung difference, o wala siya true zero. Next, when we say interval or the difference between the interval and ratio is that the only difference of interval to ratio is that ang interval wala siya true zero o ang ratio na ay true zero. So it is important to remember that the nominal and ordinal is categorized, and the interval and ratio is
numerical.
That would be all, and thank you for listening.